Okay, so I can use volume and define it. So volume is how much something can hold. So it's how much something can hold, how much matter is inside of it. So like in math here in a couple, actually towards the end of the year, we'll be doing surface area. Surface area would be the outside, what you could touch of a figure. Does that make sense? The outer edge. The volume, like the outer walls of this classroom, the ceiling and the floor would be surface area. Volume is how much air is in this room. So it's how much it can hold. So when you're looking at the volume of a 2-liter drink, the volume of a 2-liter drink is 2 liters. It will hold 2 liters of soda. Okay? We know how much it will hold. We know how much is inside of it. It's also like, think about the inside. It's the inside, like how much, if I was to measure the volume of your body, the best way for me to do that would be able to put you in find a really big graduated cylinder and dip you inside of it and measure the distance in the water.
Wait, how was it supposed to fit in there?
I said a really big one.
Oh.
So, how do we measure this? How to find volume? Obviously, how to find volume, I'm not talking about length times width times height, right? That is the volume formula. But can I find the volume of an object that is not normally shaped? Let me see if I can find a rock. I'm just going to put a rock back here. Can I find the volume of this rock? Can I find the volume of this rock?
Yes.
So there's a formula for it. How can I find the volume of this rock? Just right here. Just a little roly pebble.
Like to weigh it?
Can't weigh it. Volume's not mass. So, if you have a regular project, so this would be a rectangular prism, right? So, are we finding, is this a rectangular prism? No, it's kind of oval sphere-like, right? There's no formula for this at all. None. No formula. So this is what we're going to do. Of an irregular, this is what we call an irregular object. Because is there another rock in the world like this? Is there? Exactly like this?
No.
No. So are we going to come up with a mathematical formula for this particular rock? And
Yes.
no. No, there's a simple way to do it. So we're going to use these things called graduated sealant. We're going to use water. We're going to use water displacement. What displacement means out of place. Place or moved. How much water it moves or displaces. So when you think about, let me think how do I want to word this? Oh, you're baking a pie, right? In the oven. You put too much filling in it, what happens?
It like come out.
It boils over, makes a huge mess in the stove, right? So think about displacement as that pie in the oven. The pie filling got displaced, right? It got kicked out.
It was like flow.
Yeah. So we're going to use something called a graduated cylinder. Now, we've used beakers before. Beakers, this is what looks like a beaker. It's like a little they're a little wider. They usually go up to like 100, 150. And they're usually marked off in like 100s, 50, and they're 0. This is a beaker. Now we're going to use something called a graduated cylinder. A graduated cylinder is more exact. It gives you an exact measurement. This is more for, a beaker is more for estimation. It is a graduated cylinder gives us an exact measurement. They're usually very tall and cylindrical, which means a cylinder, hence the word cylinder. They have usually like this really odd base. Looks kind of like a hexagon or an octagon. Okay? That is our graduated cylinder, and it's marked off in little itty bitty little marks. It is marked off in itty bitty little marks. I want to get this glass one, you can see it very well. This glass one, the one we'll be using today will not be like this. Actually, this one right here might be easier. So this is what we call a graduated cylinder. Do you see how this is marked off in tenths and a beaker was just kind of like 50 milliliters when we've used them this week? It was like 50, 25. It is marked off in more of an estimation rounding. This is very exact. It's marked off in milliliters. Kind of like a meter, a centimeter is marked off in millimeters. This is marked off in milliliters.
It's like going by 5.
It goes up by 5. So there's 25, 21, 25, 26, 27, 28, 29, 30.
31, 32.
So it goes up very precisely. So that's what we're doing today. Here's a glass one. It's a little harder to see. But these little plastic things right here, so if you drop it, it doesn't break because the glass ends never ever hit. We're not using any of these today because we don't have very many of those. And I've already broken stuff this week. So, and when you read a graduated cylinder, I want to kind of draw a zoom in. It's kind of like you have this is the top. So let's say you have, let's see, 100 ml, and you have this right here. That little circle, because we're going to call this the water that's in it, because you're going to use like a teal colored water today or green colored water today. This little bottom of this line is called a meniscus. Meniscus. I know it sounds like really cute to say, right? Meniscus. And I'm not sure if I spelled that right, but I'm doing my best, okay? Meniscus. You read the bottom of the bubble. So that's the bottom of the bubble is what you're reading, okay? You do not read the edges. Do not read the edges. You read the bottom of the bubble, okay? That is how you read this. So to measure water displacement, are y'all ready?
Yep.
Okay, I'm going to turn the page. Can I turn the page? 1 second. Meniscus.
We need to get the bottom of the bubble.
Huh?
We need to get the
Because the edges come up such a minute amount that it's really not.
So is that some kind of like a chemical?
No, all this is water just been dyed. And you really can't see the meniscus very well on these. The colder the water, you see it, but you really barely see the meniscus. Like the bottom of the bubble is very flat for me.
Yeah, like it's like the little bubbles that's in it. If you shake it up.
No, honey. It's like when you fill up a drink, like you can kind of see it in this one a little better. It kind of climbs the edges a little bit. Kind of looks like it sinks down a little bit.
Oh, yeah, I know what you're talking about.
Does that make sense?
Yes.
So we're going to talk about some water displacement. Are we ready?
Yes. Turn the page.
So So we're going to talk about how to measure water displacement. How do we measure this? Volume of water displacement. So we're going to draw two graduated cylinders. You're going to make two little graduated cylinders here. They don't have to be exact, they can be rectangles. See how inexact mine are? So, then I'm going to do 10, 20, 30, 40, 50, 60, 70, and that's as high as we're going to go. I just kind of put the measurement between them, that way you wouldn't have to write it twice, okay? So we've got our little, I wonder, this is our original. We know that the original has, we're going to say 40 milliliters of water in it. Okay? Now, I'm going to drop the rock in. Whoop. And now, I'm up to here. Oh, I should have drew our rock in there. Sorry. Here's our rock. Boom. It kind of looks like a turd in a bowl, but you know. We'll make it a little bit more jagged. How's that? There we go. There's our rock. There is our rock. How much did the water change? It went up from here to here, right? This is what we call our displacement. Guess what? From 40 to 55, that is how much our water was displaced. But does our rock have a volume of 55 milliliters?
No. Wait, yes.
No.
How?
We've got to take 55, which is our new, minus our 40, which is our old, where we started, right? When we subtract the two, 1 milliliters, our rock has a volume of 15 milliliters. It's kind of like measuring your growth from the beginning of the year to the end of the year. If I was to measure you now and then measure you at the end of the year, I could subtract the end of the year from the beginning of the year and tell you how much you grew this school year, correct? When I look at your scores on your pre and post assessment, I take your new score and subtract your old score to see how much you grew. Is everybody seeing what I'm doing there? Okay, and I can figure out how to do the percentage from that.
The displacement thing, that even happened to me once. When I was putting ice in my cup, the water was up.
Yeah, so it's the same thing as water displacement.